For this experiment, we wanted to take a look at Kirchoff's law. We know that radiation is either transmitted, reflected, or absorbed. Now, for the three surfaces that we used in this experiment, one being a painted black surface, one being an aluminum surface, and one being a painted white surface, we know that radiation is either absorbed or reflected, because obviously it cannot be transmitted through these solid surfaces. Now, using an infrared thermometer, we are able to measure the reflected and emitted radiation and calculate into an actual temperature.
And we know through Kirchoff's law that the radiation that is emitted by the object is equal to the radiation that is absorbed by the object. So if we take the measurements of these different surfaces, we can find the changes in emissivity and therefore the absorptivity between each object comparatively.
We first started off by taking a measurement of the ground to measure the terrestrial radiation. After variations with the wind, we found the ground temperature to be approximately 70 degrees. Then we measured the aluminum surface, facing towards the ground. After some variation, got a measurement from around 71 to 72 degrees Fahrenheit. Next, the black surface facing towards the ground, which we got measurements of around 70 degrees Fahrenheit. Then finally, the white surface facing towards the ground, which we received measurements from around 68 to 69 degrees Fahrenheit. Looking at a comparison between all three surfaces and the ground, they all registered around 70 degrees Fahrenheit, and this should be expected. All three surfaces were approximately 70 degrees, which means they would emit at an infrared signature of about the same temperature. And since the reflected radiation is terrestrial and was also measured to be around 70 degrees, the emitted and the reflected radiations picked up by the infrared thermometer would be approximately the same. Next, we took a measurement of the sky, which registered around negative 35 degrees Fahrenheit. Then, we oriented the surfaces to reflect the radiation from the point that we had measured. Starting with the black surface, we measured around 85 degrees Fahrenheit. The white surface measured a little lower, at 75 degrees Fahrenheit. Then the aluminum surface, which dropped all the way to negative 10 degrees Fahrenheit. Looking at our measurements, the first thing we observe is that the spread is much larger than the experiment before. This was because the infrared temperature measurement from the source was much lower than the surface and the ground temperatures. Note again that the infrared thermometer only measures emitted and reflected radiation.
For surfaces with a high albedo, more radiation will be reflected than absorbed. With this being said, the high albedo of the aluminum surface will reflect the most infrared radiation, whereas the black surface will reflect the least. Keep in mind that what radiation is not reflected will be absorbed and re-emitted from that surface.
Looking at our measurements, we can tell that the aluminum side is reflecting the most radiation and the black surface the least amount of radiation. This tells us that the black surface must be emitting the most radiation, whereas the white surface the second most and the aluminum the least amount. This confirms Kirchoff's law for our experiment.